guys, I'm Septia Saputri from Saputri University Mathematics program. At this time, I will discuss about graph theory. So there are two discussions that will be discussed. So the first one, what is graph theory? And the second one is coloring problem and chromatic number of graph. Let's introducing graph theory. So what is graph? Well, the graph is just simply a collection of vertices in edges. So we say that a graph G is an ordered pair of V and E with vertices and edges. So what I mean by vertices and edges is we represent vertices by dots. So there are some dots. We can label them if we want. So we call this A, B, and X. And we have edges, so we can put them between the dots. So this is in a H, E, and this goes from A to X. We have another H called this H, F. This goes from A to B. We can have an H, D, that goes from B to B. And we might have an H called Y that goes from B to X. You might have another H called Y prime that also goes from B to X. So these are how H is work. Here's some more terminology for graph. We have a nice structure A, B, C, D, E. And we have some edges between AB, BC, DE, and AC. So what does incident mean? Well, if you take an HX, so we say X is incident to A and B. So X incident to A and B. So any H is incident to two vertices, so it's basically what are the point connecting the H. Now we have another term here called adjacency. So for an example, B is adjacency to E, C, A, C, and E. So what do you think that means? Well, if we have an H connecting it, so if we have a vertex, it is adjacent to other vertex or vertices if it had an H connecting it. So here we have an H connecting B to C, we have an H connecting B to E, and we have an H connecting B to A. So what about A? What is A adjacent to? Adjacent to. A is adjacent to only B because it's only connected to B. It's not adjacent to E because there is no edges connecting A and E. Okay, what about isolate? Well, D is isolate. And an isolate vertex is any vertex without any edges coming in or out of it. So that's why we say it's isolate, because it's just on its own. So this terminology is very important for understanding some concept that we are going to talk about. So let's discuss about graph coloring. So graph coloring is essentially the number of ways we can color graph, and we introduce this term proper coloring if we can color a graph so that two vertices connecting by H will have the same color. So essentially what this means is that if we have a connecting to B, that means that A and B are going to be different color. So for instance, because A is a pink That means that B cannot be a ping. And what if C? Well, we can do C ping again, but it means that when we get to D, we can only have it green. In fact, well, we don't have to pick green. We could pick any other color we want. But normally, what we want in graph theory is to find the minimal number of ways or the minimal number of colors we can use to color a graph. So we have a special term for that, and that is the chromatic number, which is chi of T. So this partner's chi. So we use this number to denote the minimum number of dots needed to color a graph. So for instance, let's take a look at K4. So how do we color a graph? Well, we pick up vertex to start at, and we give it a color. So let's choose orange in the bottom, left vertex, and we'll go to a new vertex and we'll pick a new color. So let's go to the top one. It's connected to orange one, so it can be orange. Therefore, we'll color it in yellow. Let's go to the middle one. Right now. Can be orange, can be yellow, so let's color it like blue. And then the bottom right, let's go with green. Because each vertex is connected to each other vertex, we know that the chromatic number of K4 is just going to be 4. So if we were to generalize this, then the chromatic number of Kn is going to be n. And this is because each other vertex is connected to each other vertex, and two connecting vertices cannot have the same color. So the next in effect, there's the chromatic of graph K, and it's just going to be n. Okay, so that's chromatic number that is coloring, but the big thing for figuring out how many colors and how many ways we can color a graph, because this is discrete mathematics, so counting is a big deal.
Okay guys, that's the explanation of graph theory and color number, chromatic number of graph. I hope this explanation can be understood well, and feel free to share this video and like the video if you support it, because there are requirements for this assignment with 100 subscribers, 600 views, and also 300 likes. So don't forget to subscribe, like. Thank you guys. I hope you enjoy it.